Hey everybody, wait, we're gonna have double audio here. Wait for it. Hey everybody, wait, we're gonna have. There we go. We got it fixed. How's everyone doing today? We'll see if anyone's in the chat. I don't see anyone in the chat yet, but we just started the office hours, and we're gonna get started here. We'll see what people want to review. I'm gonna sign back in. So much going on today. We have the test for 201. We have 320. We have class today. Oh my gosh. Let's see who's here. Mubot. Who is here, Mubot? Let's see. Hey, Kayla, what's going on? Good to see you here, Kayla. I looked over. I'm looking at the other screen for the chat. Good to see you here, Noah. Good to see you here, Noah. I'm logging in. It is 201 test day. Getting everything going right here. Got emails. We respond to later. So, yes. Sorry if I take a moment to respond to everyone's emails. So, I wake up. Oh, my gosh. So many interesting things. I got a lot of spam emails overnight. Like, does anyone have that happen besides me? Good to see you, Danielle. Good to see you, Sarah. Good to see everyone here. What questions do people have? If you have questions, let me know. It is office hours time, so you get to ask all the questions you have. You get to ask all the questions, making sure I got a bunch of work done last night. I have a few small BS 320 questions. Yeah, go ahead and ask away. I'm going to get 320 up right here. So I am getting 320 going. And ask away on 320. I like it. I think 320 is going to be very happy that they are in this email. Let me make sure everything is good to go. We have so many notes. 320. I think you're in today's class, right, Kayla? Which is awesome that you're working on this right now. Oh, man, we did that one yesterday. That was so cool. We came up with a really good 201 example yesterday for 201 class. Hey, what's up, Maddie? Good to see you. Can we go over how to calculate percentiles for the normal curve? You bet. You bet. Noah, you got it. Is the key assumption for linear regression the fact that we assume... well, let me see. Let me read the question again. I think I put like a hint on it. Okay, let's hop over to the main screen. Could you show at some point the chart organizing bivariate, univariate? Yeah, let's do that. Here, we'll do that real quick at the start, Maddie, since that's really easy to do. And I think we'll do Noah's question after Kayla's question here. So, and good to see her, Lauren. I don't know if I said hey to Lauren. And Mubot's here.
I am Mubot.
Good to see you too, Mubot. Let's go to the main screen right here, and there we go. Main screen. Here we are with the main screen, and let's bring up the all graphics. Gosh, you see me like squint there. I'm so blind. There's all the graphics, and so is this what you're looking for right here, Maddie? Here's all the graphics. How can I produce a nice table for the summary function? I do not want the output. Oh, good question right there, Kayla. That we'll handle that complex question. You're welcome, Maddie. That is the graphics showing all the organization. Definitely take a screenshot of it. And so that way you can have all the everything. Oh, you got the screenshot. Awesome. Great work. Let's throw some 50 points out here. It's so interesting. I was looking at points last night because we're writing a paper on this. If you didn't see, we have a paper being published on what we're doing. Jump question. You bet. Daniel, which one is that, Danielle, right there? We'll do that one after I think Noah has a question, and then we'll do the Danielle's question right there. Assumption. Wait, there is a key assumption for the linear regression. Yes. So this right here, briefly describes something if you see any issues with it. So the key assumption for linear regression, I almost put a hint. Let me put this right here. And so what is the key assumption for linear regression? Like, to do regression, we have to have two quantitative variables. So you kind of go back to 201 with this question. This is a good 201 review question. What is the key assumption for linear regression? And you go back to 201 with QQ, straight enough, no outliers, plot doesn't thicken. Those are all things we'll talk about in 320. But what is a key assumption for linear regression? What is a key assumption for linear regression? And I don't know. I don't have a regression saved anymore. Exactly, that a linear model goes through it. Because basically, just think about what we're doing mathematically. Great job right there, Kayla. We're taking, and I don't have any data sets loaded. Data, survey 10, attach, survey 10. Oh, I already had it attached. Okay, cool. Do not have this output when you knit. Don't have that. A few people have had that repeating a few times. And so I've got it attached now. I'm just making a quick model right here, and we can see it. LM, height, weight. Sure, I'll do it correctly. There we go. And I'm going to see if we can make the... and great job. And you're doing this, right, Kayla? I think I'd say which one to use. I say use the visualized model, so it should be pretty obvious. The visualized model is a function, Dr. Petrie. Oh, question. Yeah, Parker, put one in the chat and we'll do it. And we also did those yesterday, too. We got, I think, two or three questions ahead of it But we can do that, Parker. Got Noah's and Danielle's, and then Maddie's wondering too. And we did those yesterday, and I've got them marked in the video from yesterday. So if you're looking for those right now, so let me go grab those from yesterday. So yesterday's office hours. Oh, did I not add this? 2 seconds. I'm gonna add to this right here. Add videos. Your videos. Does this have yesterday's video in here? Oh, I think it does. It's just yesterday's is not first video anymore because I put this one first. So yesterday's video right here, we did chapter 8. I'll put this into the chat. So yeah, the notes mentioned plot. I'd use visualize model. It's just way better. It's way quicker, way easier. And I think it's later on in the notes. It probably is. And so you can see right here, we start doing the animals in gestation problem. And we start doing the other ones. I'll come back and do this though. But if you're looking for chapter 8 right now, we have some chapter 8 problems solved right here. And as always, you can check the things right here. And we got cycle times, all these right here in this video. So the visualized models, the quickest way to get a really good model for this, we will accept the other one. But I like, oh, no worries, Parker, great. And if you're stuck on one or you have questions on one, let me know. And then I always, since today's test day and everything, I'm like, oh, let's do as much as we can. And no, you're welcome, Parker. So I'm trying to think, Kayla. Let's think, right? Buffering? Is anyone else buffering? Oh no, don't let this be one of those days. I keep thinking it's sudden link, and we didn't have any issues last semester. It sounds like it might be you, Maddie. Just for a second, okay. Are we good again now, everyone? All good now? Yeah, sometimes there's like a 1 second buffer. I don't know if it's YouTube or sudden link. I've been trying to narrow it down, and Suddenlink said we have the best and fastest internet. And I was like, okay, thank you. It doesn't help me. I can't pay you more for my internet. And they're like, no, you got the gigabit internet. And I'm like, well, I wish you had better internet because everything I have seems to be good. I'm probably going to switch over to OBS and see if that fixes the buffering issues. It's just a major switch. And I'll probably try it like on a Friday stream to see if we don't have any issues. I just have to get everything reorganized and everything. So you're saying, Kayla, when you knit it, the summary output does not appear as nice and neat. I think when you knit it, Kayla, it should. Here, 2 seconds. Class is not over. Then we'll do next question here. Let me go to knit. When you knit the summary output, it should appear nice and neat. I'm just going to knit this. Okay, it's error. Oh yeah, I have a wrong sample size in here. 2 seconds. Class is not over. I need like a thing that bounces back and forth on the screen. Okay. Everything's all good now. Error on line 94. I'm just fixing my errors right here. Oh, because... Okay, let's see if it knits now. Knit to Word. Okay, it looks like it's knitting. Let's see here. Okay, class over screen on. Okay. Are you talking about this, Kayla? This doesn't look so bad. I've got a few regressions in here. Yours should look like this when it knits, and then you can like type up. You won't have to use jump on the test. You will have to read jump output. So you will have to read jump output. So I think this looks pretty good, Kayla. Like your regressions can look like this, and your summaries can look like this right here. I've just got a whole bunch of output on the screen, and with the summary output, it should look like this. Is that what you're getting, Kayla? So it should look. I think it looks all right. We can figure out a way to improve it here. If you have one, let me know. I'm always for making things look better, but this is 100% acceptable. And I think the next question was, oh yeah, email me on that, Kayla, and let's figure out a way. I bet there is a way. So let's figure out a way to make it look better. So email me on that, Kayla, and that'd be really cool because I always like when things look even better. So you could take the output from it and make it into its own table. It'd be a little bit of work. So maybe we need to work on the code together. There's a cable? I've never even tried that. Email me what you have and what you want it to look like. Like maybe just do a small like version, and then I'll try to figure out the code. So, or put it in Discord. Maybe we'll figure it out on Discord. I keep forgetting Discord. The next question was, could you show at some point? Oh, we did that one. And then I think Noah had a question. He said, can you cover how to calculate percentiles for the normal curve? Let's talk about calculating percentiles for the normal curve. I think I got everything. Don't save. Here we go. Word document. Class is not over. Percentiles on the normal curve. Are you ready? Here's how to get percentiles on the normal curve. is the first percentile on the left or the right of the curve? You should know this pretty instantaneously. Is the first percentile on the left or the right of the curve? This is something we should know pretty instantaneously. Is the first percentile on the left or right? Oh, really? That's in NIDAR? So I didn't know that. There's so much. Kayla, thank you so much, because there's so many functions I don't know or don't use. Nice job, Aaron and Noah and Maddie. Great job. The first percentile is on the left of the curve. So I always ask students, do you want to be in the first percentile of the test or the 99th percentile of the test? The first percentile or the 99th? And the answer should be the 99th. I mean, if you want to fail the test or do poorly, then you'd want to be on the first. But we want to probably be on the 99th. And so when you think about percentiles, they go from left to right, like first, second, third, fourth, 10th, 20th, 30th, 40th, 50th. And then we see some interesting spots. Like right here's the 84th, right here's the 97.5th, and right here's the 99.85th. 99.85th. I misspoke there. How do I know this? So the first one we can do, which is the easiest to do, is going left to right here. And how much area is in here? These are numbers we must instantaneously know. How much percent is inside here? How much percent is inside here? This is inside of a z-score of negative and positive 1. Negative and positive 1. What percent is inside negative and positive 1? 68. So we next have 95. This is called the empirical rule. And then we have 99.7. These are the numbers we must memorize: 68, 95, 99.7. It's funny, it's like I don't even know how I can't know them now. 68, 95, 99.7. I'm just like, how do people not know these numbers? They're burned into my brain. So now, how would we get percentages from this? So the way to get percentages from this is going to be to probably let's start with the lowest one right here. Now, if 99.7 is on the inside, what is total on the outside? If 99.7 is on the inside, what is total on the outside? Like 99.7 inside, total outside is this. So you got 99.7 inside, and then total outside. Thank you so much, Maddie. I love that. I've literally had people, I say it all the time, they've yelled it to me on the strip. They were like, QQ, straight enough, no outliers. And I'm like, what does that mean? They're like, I don't know. And I'm like, look, I failed you. So 0.3 is on the outside, and then 0.15 is in either hand. In class, we would usually chant out QQ, straight enough, no outliers. QQ, straight enough, no outliers. We'd get going before the test. I'd be like, come on, let's get some. Oh, man, we would do it like in the auditorium. Okay, I'm just having reminiscing memories. Like in A&B auditorium, and sometimes we'd be in there with another class. Like it'd be our class, like 300-400 students from our class, and like 400 students from another class. And that'd be like, come on, everyone, let's start the QQ chant. Everybody be like, QQ, straight enough, no outliers. And everyone starts chanting it, and other students are like, what the heck is going on? What class is this? Okay. 95% inside, total outside is what? 95% inside. So if you're wondering what I'm doing, I'm saying right here, 95% of the area is on the inside, as in between here and here is 95. In between, and then I'm asking, what is outside? And so, Daniel, I think you're on the right. I know, I miss it too. We'll be doing it again soon. And Maddie, thank you so much for being here and participating. And if I can give one big thing of positivity, it's say something in any other class than mine. No, like I want you to keep talking mine, but go to another class and say things in chat. I promise that'll make your instructor's day if people are chatting in their chat, because it really makes my day that so many people come here and they interact. That really means a lot to me, that we have so much interaction, we have so much discussion. People can just say things like I miss in person. Like you can just talk like this is a normal chat room, and we're just like, like having discussion like we would during office hours. And so that means a lot to me, and I'm sure it means a lot to the other instructors too. So say something in another class, and also my class. So we're gonna do the last one right here, 68 inside. The total outside is 32. If you're wondering how I'm getting these numbers, someone's like, Brian, I just don't understand. That's all right. So what we're saying is 100% is in this curve. So we take 100, we subtract out the 68 to get 32 is left on the outside. And then what are we doing to get the 16 right here? So just think about like, how are we going to get from 32, 16? So we had 68 inside, 32 outside, and then how are we getting 16? How are we getting 16? What are we doing to 32 to get 16? You can tell me what to type. Probably a quick way to tell me. Exactly. Great job right there, Reagan and Leslie. Good practice. And so the question was, how do we get the percentiles on the normal curve? Well, this is going to help us get the percentiles. And we might have questions that show you David M. Lane pictures that could ask you about the percentile. Once again, if you're watching this part of the video, you should know that like the first percentile would be down here. Why do I know the first percentile would be down here? Like the first percentile would be somewhere. It doesn't look like it. It's because my drawing is bad. I do know the z-score for the first percentile. It's 2.3263. Which that's about at 2.3263. How do I know the first percentile is here? How does Brian know that the first percentile is there? Let's think about that. The first percentile is there, and I know it because right here at this spot, what percentile is this right here? What percentile is this right here? What percentile is this? So what percentile is this? Let's do this. Perfect. Let's go across all these and fill in the percentiles. Look at that. I love copy-paste. Who doesn't love copy-paste? You are correct. And we're just doing what percent of area is below this. So we're just saying what percent of area is below this. This is the 0.15 percentile. So that's the 0.15th percentile. So you just have to ask what percent of area is below this. So now we have to ask what percent of area is below the next question mark and what percent of area is below the next question mark. So just ask yourself what percent of area is below the next question mark. That's all you have to ask yourself. You go to this question mark right here and you say what percent of area is below it. 2.5, exactly. Great job, everyone right there. Lauren and everybody, 2.5. Be writing this down with me. It's the best way to practice. Someone just grabbed some paper right now. And so what percent of area is below this? What percent of area is below this right here? I'll do the next one. It's the easy one. You're like, come on, Brian. That one's not fair. That's so easy, the next one after this. Or maybe I should do the one after that. I'll do the one after that because that's a little bit harder. People often forget how to do the middle one right there. I mean, once you see it, you're like, oh, it's so easy. 16, great job right there. This is the 16th percentile. And all we're doing is we're just going right here and saying what percent of area is below it. And the next one is going to be, what is the next one? People do forget how to do this one. People, wait, I don't have any numbers for this one. People do forget how to do this one. They say, I don't have any numbers. How do I do it? Nothing on the curve tells me what's going to be below that. But just take a look right here. And that should give a huge hint. So you're just looking at the percent of area below that. Exactly. That's exactly it. Yeah, and I like that you put a question mark there because a lot of both 3 question marks. Wow. No, I love it because I think once you see it, you're like, oh, it's the middle of the curve. It's like once you see it, you're like, oh, I see how people could be a little bit confused on it. So now think about this. If 16% is above here, then what would be below here? That's probably the easiest way to get this number. If 16% is below here, then what would be above here? Well, then if 16% is above, then 84% is below. And then we can go right here and say if 2.5 is above, then what would be below? Well, then 97.5 would be below. And you can't write with an eraser. If 0.15 is above, then what would be below? Then 99.85. You know what's really interesting? If you get all these numbers right here, you can actually get the amounts between. So you could actually fill out the remaining numbers. We're on purple today. So you could fill out the remaining numbers here, like 2.35 is the area between there. 13.5 is the area between here, and 34. And I don't know if it'll let me copy those, but now it's just symmetric at this point. So there's symmetry to the curve, and then because this is the area between these, like, and this is above this point. It's not between 3 and 4. It's above that point. But with this right here, we just found another way basically to draw out all the numbers on the curve and realize that this 0.15 is below -3, and it's also the area above +3. It's not between 3 and 4. I have mistakenly made students think that sometimes. It goes from 3 to infinity, which is basically very little to no area. Does this help everyone right here practice? If you can draw this out, you pretty much understand the empirical rule. This is the majority of the numbers we can get from it. We have the area between certain things, like what does that 2.35 represent? That 2.35 is the area between here and here. That is what 2.35 is. What does this 16 represent? This 16 represents the area below here. This is the 16th percentile. So that's what the percentile is right here. What does this 34 represent right here? This is 34%. Another way to get that is half of 68. So if you see right here, 34 is half of 68. And so you can also see visually right here, this 34 is half of 68. Does this make more sense to everybody? And is it hopefully, like, if you can draw this out, you really understand the empirical rule. We shouldn't be able to fool you with any empirical rule questions. But it's just practice. It's just being able to write these numbers down. And the more you understand them, the better you are. I think that does it for percentiles on the curve. Noah, I hope that helps out. Noah, did this? Awesome. Thank you. Noah. Yeah, Noah, you're the one who asked. And so, yes, Noah, I'm glad that helps out and seeing the percentages right here. We're 21 minutes in, and we've already answered 2 big questions. We got a lot of Chapter 8 questions. We can loop back to that. There was another one. Someone else had one more question. Noah said, can you calculate the percentages? And I thought there was one more. Wait, here it is. Danielle said, can you go over the jump question on the 201 practice test? I wish I had a queue where I could store stuff. Exactly. No, Leslie, you'll be all right. You got this, Leslie. So let's see right here. Which one is it? Which question on the practice exam do people want me to go over? Which question on the practice exam do people want me to go over? Which question on the practice exam do people want me to go over? It is your review. It is your choice. You get to pick. Question number 4. Let's do question number 4. I think it's the hockey time one, right? So let's do question number 4. There's a way to do question 4 that makes life really easy. Okay, so question number 4, I'm going to go ahead and take right here. Oh, it's such a big screenshot. I think, okay, we should be able to zoom in on this. 2 seconds. Let me get question number 4 right here. I'm going to go ahead and take it. And we got it. And there we go. Is it clear? Yeah, it's clear enough. It's clear enough. Okay, good. We can read it. We had one semester where the printers could not print the numbers clear enough, and it was not fun. So let's go ahead and take a look at this question right here. This time, I think it was this semester when we had this one. People couldn't read the numbers, so we were like writing the numbers on the board, and I was just like, oh my god. No. Now we just have computer issues, and I don't say that lightly. We do have issues where computers won't load the exam, computers are crashing. So it's administering exams to over 1,000 students is always an interesting task. And we're here to make it work as best as possible. The reaction time of The reaction time of a professional hockey goalie was measured many times. And we get a normal distribution from it. Okay, that's a key assumption right here. We do need to know. We've covered a lot in class and during office hours, how to check if things are normal. Make sure to watch those parts of the video. With an average of this, and so this is the what. I'm going to circle this, and I want people to tell me in purple, I've circled the what. And then in green, I've circled the what. So I've got some numbers right there. In purple, I've circled the what. And I'm going to do a harder version of this question next. Exactly. Mean and standard deviation, we're going to do mu and sigma. So, yeah, I mean, we should know notation, mu and sigma. But you're 100% right. Great job right there. Let's throw some 50 points to the chat. Nice job, Kayla, right there. Great practice. So mu and sigma, and we have right here the mean and standard deviation. And what is the 75th percentile? Now, here's where our previous graphic could really help us. The 75th percentile should be somewhere between where and where. Now, of course, we're going to use the graphics below to solve this, but the 75th percentile should be between a z-score of what and what. The 75th percentile should be between a z-score of what and what. We just did this problem a moment ago where we graphed out the percentages between 0 and 1. Between 0 and 1. Let's see if this helps us at all for this problem. Okay, so this graphic right here on the left is immediately eliminated. This one right here is going to be eliminated because, yep, great job, everybody. It is between 0 and 1. Excellent job right there, Noah and Maddie. So this graphic's eliminated because these z-scores are outside of that region. And then we see right here, this one says 75%. Okay, so 75% sounds good. But that means the shaded part is 75%. So how much are each of these worth if the total shaded area is 75%? If the total shaded area is 75%, how much are each of these worth? How much are each of these worth if the total shaded area is 75%? The total shaded area is 75%. So the total area, as in like all of this, is 75%. So then each of these would be worth 37.5 exactly. So this is 37.5. And I always say to my students, write on the graphics as much as possible. Like, I know you can't right now, but when we do in-person tests, I'd be like, write on the graphics, do what I'm doing right here where I draw out the percentages, print out the practice test, practice doing this, like drawing the numbers on here. So this right here would be the 62nd 0.5th percentile. And that would be the 37th percentile. So these are not the right spots. And this graphic right here is just the same image, but the image is kind of mirror imaged, or not mirror image, but kind of alpha reverse color. I don't know what they call it. It's kind of just the same thing, but black's white and white's black. So that only leaves this graphic, huh? Well, let's see what's going on right here. This is the what percentile right here. This is the what percentile. This is the what percentile. It's 25% shaded, so that's 25% shaded. So what percentile is that? That's 25% shaded. I learned and retain math so much better when I... Exactly. Writing it down really helps. I wish I'd started doing that when I was a kid. I do a lot in my head, but writing it down also helps with your memory, so it's a big thing. This is the 25th percentile because there's 25% below it, so that's what the 25th percentile is. But we have a bit of an issue. We don't want the 25th percentile, we want the 75th. So let's do a little drawing of what the 75th percentile might look like. The 75th percentile would probably look something, it'd probably look something like this right here. Like the 75th percentile is what we want. And it would probably look something like 25% shaded. And this would be 75%. I mean, what are you noticing right here if we say this is what we want? Oh, yeah, well, you should. And if you do that, you can do that, Clay. And if you get it wrong, just let me know. You are more than happy to use inverse norm 0.75 and then 150. So inverse norm. So that is, if you know the things. So it'd be inverse norm. And then it'd be 0.75, comma, 150, comma, 10. That's interesting that it was off by that little amount. And so that's how I do it. Nice job right there, Clay. That is a way to do it. And so you can use it totally every time. It's the same as the 25th, but the opposite sides of the graph. Exactly. So if you think about this, let's make this problem really easy, though. Let's make this problem really easy. You ready? Let's change this number here to 143. So now what I'm saying is this is at 143. So now, oh no, just tell me if you ever get things off by that little, and I'll correct it. So now how much below, so this is at 143 now. Or send me your work too, because I'm interested to see. I want to check it out if it's off by the tiniest amounts. And I correct a lot of things for people. Like if you say, hey, Brian, I got this off by 100th, or I didn't add an extra decimal, I'll usually change. There are things with the T and the Z, though, that I'll be like, no, it looks like you used the Z. I'll always make clear if I'm giving points back or not. And I give a lot of points back. So how much below is 143 from 150? We just rounded 140 something, 143 to yada, 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 yada to 143. So how much below 150 is 143? How much below 150 is 143? How much below 150 is 143? How much below 150? How much below 150 is 143? So we're just asking about this distance right here. 7, exactly. So with it being 7 below, then, exactly, Maddie, exactly. And so then what would we do to find our answer? You can look at that right there. We're just trying to find this right here. So if we're trying to find this right here, then what should we do? What are we going to do right here? And does anyone see what our answer is going to be if we're just trying to find this right here? Like what the answer we're looking for is, let's go gold pen. The answer we're trying to find that right there. We're trying to find where that point would be. So because that's just the top 25% or the 75th percentile. Exactly, Maddie. Great job. It's going to be, it's just going to be 157. And this is the rounded version of the problem. If you're doing the exact version of the problem, we can use the real number down here at the bottom. The real number is going to be, let's remove this. The real number is going to be 143.258. And so let's take 150, subtract from it 143.258. All we're finding here is the distance it is below. And now we take that distance below and we just add it to 150. And that's the exact version of the problem. Does that make sense? It's basically 157. We used originally just a rounded version of 143 to show that we're just finding how far below it is. And then we're just going to take that distance and flip it. And that's what you see going on right here. We're just saying, okay, this is the 25th, but we really want the 75th. So we're just going to flip it. Yeah, so I think seeing it this way where it's just like, okay, here's the lower side. Let's just flip it around to the upper side. And then we've done it. So hopefully that makes a lot more sense on this problem. And kind of understanding how to look at these graphics is important. Awesome, Maddie. So glad to help out. And that's what you got for your answer. You know what I'm going to do? I'm going to solve it in R. Watch this. So R is really great. It has a function here, basically like your inverse norm. So just a really quick thing on R right here. R has Q norm. Is it Q? No, it's P norm. So we want P norm. And P norm should be the percentile because the percentile in the we want Q norm. Q norm, watch this. The 84th percentile right there is that. And here's the Z-score for the 75th, which is 0.673, 0.673, 0.674. There we go. That 3 I was not sure of. And then we put in the mean and the standard deviation 10. There it is right there. 156. And what did you get? Let's throw some points here. Yeah, that Clay, there's the answer I'm getting. And let me do this. Options, digits, equals, we don't want to go too crazy. There we go. There's something right there. And let's throw Clay, great job on that. Let's throw some points to Clay and everyone. Let's add 20 points to the chat. That's what you got? Yeah. This is the exact version right here. And if you notice, knowing how to do things like this is the inverse norm function inside of R. So I'm doing the same thing you're doing, but yours would say inverse norm. So you put in the percentile you want, the mean, and the standard deviation. So this is percent, and then this is mean, and then this is standard deviation. So similar function, and that's why I love coding, because you can get the inverse norm like that. And then we found out the answer. Speaking of, really briefly, let me see right here. Here it is. Is this it? Let's run it. There should have been a lag burst right there. Sorry, everyone. So the thing did where it looked like it starts restreaming. If you have questions right now, it's now time you ask. Sorry, everyone. I do not know why it's been doing that this semester. I've been trying to investigate it. So who has questions? We're still streaming, right? 2 times today. I don't like that. Sometimes it happens like randomly once a day. Sometimes it's pretty random. And I'm probably going to switch to using OBS, not Streamlabs OBS. Can anyone hear or see me right now? Chat, how are we doing? It is your time to ask questions right now. Any questions you have, feel free to ask. I'm sure, is anyone stuck on or has a question on anything on 201 test? We got like 20 people watching. I don't know why we hit those lag bursts. Let's see, any questions? Can anyone hear me? Yeah, I know. Well, it's so interesting. What happens is all of a sudden the chat restarts. And that's when I know that there's like a major buffer. So I think you're right, Kayla. Like I saw it too because my chat restarted, and then I noticed when people would say, and happens like once every 3 or 4 streams these days, and I do not know why. It just started randomly happening this semester. I'm probably, like I keep saying, going to switch over to Streamlabs OBS. I had a couple questions about assignment. Well, it is you got the floor, Kayla. Go ahead and ask away. It is anyone's time to ask any questions. Kayla's got the first question. Do we need to set a seed on anything? Yes. Wait. I don't think you need to very much. There is a seed reminder, right? I don't think we need a seed on anything because I don't think there's any randomness procedures. Great job right there, Snea. We don't need. Sorry, Parker, about that. I'm so sorry. Whether I don't even understand. I don't know if it's sudden link. I don't know if it can't be YouTube because everyone else is not having this issue. So it's got to be either sudden link or Streamlabs OBS. And I'm probably going to try to switch to OBS this weekend. It's just my Stream Deck's not configured to it. Oh, good. Yep. I don't think we need a seed on anything. I've got the seed reminder, but linear model does not use randomness. So I don't think we're using any randomness procedures. So I think I'm 99% certain because we're doing confidence intervals, we're doing a linear model, we're doing ANOVA. None of those use a randomness procedure. So great question right there. No need to set a seed for any of the code. Linear model does not have a seed argument. ANOVA does not have a seed argument. Confidence intervals do not have seed arguments because they don't use randomness to produce the results. Now, bootstrapped confidence intervals do. Bootstrapped confidence, bootstraps. That's Will's dad, right? In Pirates of the Caribbean's Bootstrap Bill, isn't it? Bootstraps. We have bootstrapped confidence intervals in statistics. I've got here lifesavers. Could you go over a Mosaic plot question? Sure, yeah. I think there's one on the test, right? Great question, Lily. No, I think it is a little bit easier, and also I think your experience helps. I think it's like a dual thing. Like you've got more experience, and it is a little bit easier. So with that right there, I think it's like a win-win. So let's do it. Let's do a Mosaic plot question. Great job right there. I'm glad to hear that. I like hearing when people are like, it feels like it's a little bit easier. And I'm like, well, because you're getting better, and it is a little bit easier. So awesome stuff. Let's look at some Mosaic plots. Okay, so this is one of the test questions, but we're going to turn it into a Mosaic plot. So let's see right here. Let's open up Jump, and let's take the question, why can this be put into a Mosaic plot? Why can this be put into a Mosaic plot? This is a good question. Why can this be put into a Mosaic plot? We should know instantaneously why this can be put into a Mosaic plot. So while I'm putting this in here, let's put here age group. I hate when age is groups. I'm not joking. I actually really hate when we do age groups. Why can this be put into a Mosaic plot? Let's put here promoted, or let's do status. Why can this be put into a Mosaic plot? I'm kind of doing a bigger version of this problem. So why can this be put into a Mosaic plot? Age group. So up to 39. Exactly, two categorical variables. That's exactly it. Great job. Two categorical variables. Nice job. Remember, we do have our graphics right here. It's two categorical variables. So Mosaic plot, contingency table. So I'm making the other version of it. This is obviously not required for this problem. So I'm just making the other side of it, or the other part of this output, because I want to see it. I want to see what's going on right here. It's going to help us kind of visualize what's going on. And so we got 39 promoted is 38, 82, and then we got promoted 40 and over. So promoted 40 and over, and then not promoted 40 and over is 88. Okay, so we're going to get the same output for this by going here to Analyze, Fit Y by X, and we're going to see if somebody's age group explains their status. Remember here, age group is the X variable. It's doing the explaining on why someone would get promoted, which is their status. This one we have to put in the count here, which is just the amount of observations, but it is still two categorical variables. Ooh, this should pretty much answer the question about whether or not there's an association. Who knows instantaneously whether or not these two variables are associated? There is multiple choice. Just like Canvas contents, thank you, Kevin, for asking. Just like Canvas content quizzes, multiple choice, fill in the blank, true, false, lots of options right there. Multiple choice, fill in the blank, true, false. So lots and lots and lots of options. So lots of options. So they are not, correct? They are not. And so why are they not associated? Because if you look at people who are 40 and over, it looks like they get promoted at about the same rate as people who are up to 40. So there's not much of an association. Does anyone remember what the p-value will be from yesterday? This is actually really important for 320. Since these are not associated, the p-value should be very what for this? Like, since these are not associated, the p-value should be very what for this? Like, it definitely looks like they're not associated. 320 should be like, oh yeah, the p-value is going to be very this. Exactly, Clay. Great job right there, Clay. It's going to be above 0.05, and it is very high. So these do not look associated at all. You can see the p-value down here, which is the test. And if we put it right here, so remember, this one is going to have, so don't worry, Kevin, this was a tricky question. Let's throw some 20 points right there for everyone taking a shot at this question. You do not need to know this at this point, but in 201, here's the null hypothesis. Age group is associated with status. And then the alternative will be age group is not associated with status. So what would you say right here? Would you continue to believe age group is not associated with status, Or would you reject that age group is not associated? Did I get that right? The null is that age group is not associated. The alternative is that they are associated. You're looking for evidence that they are associated. I think I just made a mistake and reversed it. So it looks like we would still believe they're not associated. So I would say I fail to reject the null that they're not associated. I continue to believe that. I do not have evidence of an association between age group and status. So let's take a look right here. What percent of employees were promoted? What does it sound like we're talking about here? A certain group or all employees? It says what percent of employees were promoted? So what percent of employees were promoted? Does it sound like I'm talking about a group of employees or all the employees? All of them. Great job right there, Reagan. So it sounds like all the employees right here. So let's go right here and solve for all the employees being promoted. And we have promoted 81 over 251. What's that going to be? Times up by 4. It's going to be right about, my brain is breaking, 320 or 32%. Someone correct me if I'm wrong, but probably 32.5% or so. 32.5. Let's find out the answer. I say 32.5%. So 81.251, 32.3%. I'm wrong. What percent of employees up to age 39 were promoted? So now this sounds like a what distribution. It says what percent of employees up to age 39. So this sounds like a what distribution right here. If we say what percent of employees up to age 39. So just a keyword you should know. When we say like, I could say here, given that people were in the up to age 39 age group. So we're talking about only employees who are up to age 39. So if I say what percent of employees up to age 39, I'm talking about a what distribution. So I'm setting something conditional. Great job right there, Hannah. We are setting a conditional distribution. We're saying, here's my condition. We're only talking about these people. So let's focus in on those. And what percent of those individuals were promoted? Well, then right here, we're going to see 38 over 120. That's basically a little less than a third. So that's going to be like 31.8%. Oh, I'm getting so close these days. Oh, I guess I was wrong, so it should be right. There we go. Sure. And so there we go. That's the conditional. What percent of employees over 40 were, so all we need to do here is realize that we're doing a conditional for employees over 40. And there you go right there. And so now we're doing another conditional distribution. Who knows the mathematics on this one? Who knows the mathematics here? So be typing out the mathematics for this conditional distribution. I always like to pause, make sure people are solving this along. Of course, I could get it wrong. You never know. And so that's basically the same. It's going to be like 32-ish%. Yeah, about that. Yeah, 32, let's say. 43, 1, so 32.82. There we go. And that's another conditional. What percent of promoted employees? So this is where the conditional distribution changes. So given someone was a promoted employee, so what percent of promoted employees of promoted employees were 40 or over? So the percent of promoted employees that were 40 or over. What is the mathematics here? What percent of promoted employees? Like given someone is a promoted employee, what's the probability they are 40 or over? Given someone is a promoted employee, what's the probability they are 40 or over? Exactly. Great job right there, Parker. And so we're just taking those numbers right there. Practice this. Make sure you can get this. And these are conditional distributions. And so that's going to be a little more than half. So 53.08. Really? There we go. And then we should ask things like, does this show evidence of an association? So does this show evidence of an association, yes or no, for people, like what if we used to have written responses more so on the test? What if it said, is there evidence that somebody's age group is associated with them getting promoted? What would you say here? Is there evidence of someone's age group being associated with them getting promoted? What would you say here? I'll put the graphic over here on the side, which hopefully makes it very clear. Is there evidence of somebody's age group being associated with them getting promoted? Is there evidence of somebody's age group being associated with them getting promoted? Is there evidence of someone's age group being associated with them getting promoted? And you see, watch this. Let's hover over this and let's see what it says. That says 32.82 right there. If you see that number right there, that's 32.82. That's the 40 and over who got promoted. And then we hover this. What's this going to say? 31.67. Definitely no. Great job, Parker. It's definitely no. And let's think why on this. And can I make this go here? Cool. If we hover over this, look what this says. You gonna do it? You can do it? Oh, won't do that one? That's not fair. It's too small. If I did hover over this and it did say something, which I wish it did, it would say 32.27, which is for all employees. So think about this. If you are 40 and over, the probability you get promoted is 32.82, which is what we found there for question 3. If you are 39 and under, or up to 39, which, yeah, there we go, then the probability you get promoted is 31.67. So look at these probabilities. They're very what to each other? They're very close, which basically means the differences here could be by what? By random chance. Those differences are likely by random chance, which means the p-value, which is a topic we talk about in a lot of classes, is very high. The differences we observe between the two groups is just likely by random chance. Yes, there is a difference where the people who are over 40 are getting promoted more, but the differences are probably just due to random chance. I don't really think there's a difference. It's like, imagine, here's a good way to think about something being by random chance. If you race your friend every week and you race them 100 times, and your friend beats you 51 out of the 100 times, do you think your friend's really better than you? If your friend beats you 51 out of the 100 times, so you beat them 49 times, you do a race, you always have this, let's race to the end of the street. Every day you say, we're going to race to the end of the street. You'd say the differences between you on who's the fastest is probably just due to what? I mean, your friend would be like, I'm better. I won 51 times. You'd be like, well, yeah, you've won more, but you've probably, I could have maybe won, in another universe. The me who raced you with the same skill set would have maybe won more often. I mean, you would maybe won more often too, but the differences we're seeing between us is probably due to random chance. But then you're friends with LeBron James. I mean, he's our friend. Everyone's friends with LeBron James. And so LeBron comes over and you're like, okay, let's race LeBron. And he beats you 99 out of the 100 times. I mean, he was probably just being nice that one time. He's like, I just feel bad. He's like, come on, you can do it. You're running next to him and he's going ahead and you're like, oh. It brings running memories in high school. So do you think the differences between you and LeBron are due to random chance, or do you think LeBron's actually better than you because he beats you 99 out of the 100 times? Would you say, nah, it's probably just due to random chance that he's winning? Random chance that he just won 99 out of 100 times. Probably just due to random chance. At that point, you would say the differences between you and LeBron are what by random chance? If he beats you 99 out of 100 times, you'd probably say, yeah, those differences sound like they're very what by random chance? If someone beats you 99 out of 100 times, you'd say those differences sound like they are very what by random chance? Those differences would sound very unlikely by random chance. And by that, we're saying a low p-value. So here's how likely these differences are by random chance. And these small differences look very what by random chance? They look very likely. Let's do this though. Let's do this example with differences that are not likely by random chance. Great job right there, Reagan. Excellent work. So everyone 20 points. Reagan, thank you so much for that answer. Excellent work. And so let's make this look not by random chance. And please ask another question. We definitely got time for another question. So what if we had here more of these employees were promoted? And now look at these differences right here. Look at these young people like myself, totally young people. Next year I'm old. Now look at these differences. Now we're seeing that of the up to 39 group, 81% is getting promoted. You bet, Clay, we can do one next. You got it. We can see that 81% are getting promoted here. And then over here, we see that 32% are getting promoted. And these differences are not likely by random chance. The differences we see between these two groups right here, between the conditional distribution here and the conditional distribution here, are unlikely by random chance. Let's go grab that question. Floor is open. Clay has said question 3, part 3. And so question 3, part 3 kind of uses the idea of the normal curve. And let's see. it sounds trickier than it is. Like when you see it, there were some O's when we did it last time. They're like, oh, I get it. I see what you're going for. Okay, so what we're going to do is we're going to first draw out our normal curve to help out. And great question, Claire, right there. We're going to draw out the normal curve, and we need to first identify that this curve is approximately normal, and it has a mean and a standard deviation as follows. Mean, or that's standard deviation, and then mean. So this is mu, and this is sigma. Mu and sigma go as follows. We're just skipping down to the last question right here. So we got mu, and then each distance up is sigma, and we usually go 3 sigma up and 3 sigma down. We're going to go away from gold pen here. And so let's go ahead and draw out the curve in this question above and think about how we'll solve this. So when we draw this curve right here, we can do better. I'm going to draw normal curves for a decade. It's my best normal curve. That's the best one I've ever drawn. It's up there. There we go. That's good. Standard deviations. And there we go. Okay. So this question asks, David has a z-score of negative 0.55. So when you go to a z-score of negative 0.55, we need to know that the z-score is on the 0, 1 curve. And what do I mean by that? The mean of this curve is 0, and the standard deviation is 1. This is what's called the standard normal curve. The standard normal curve has a mean of 0 and a standard deviation of 1. And in these spots right here, the big N stands for normal. The mean is what is the first number, and the standard deviation is what's the second number. So we see right here the normal shape of it. That's what the big N stands for right here. We see here the mean of it. That's what number goes right here. And then we see here the standard deviation of it. And the standard deviation is the distance we have right here. So important, you kind of see all these right here just with the different spots. Just understanding the notation is kind of key if you ever have to draw this out. So now we want to talk about David, and we want to say what % of customers had a wait time longer than David. Now, with a good drawing right here, we can probably deduce it pretty quickly. But what if there was an additional answer, A, B, C, D, E, F, G, and G said 85%? So we're adding an additional answer right here. So we want to know David with his z-score of negative 0.55. There's David's z-score. And we want to know what % of people had a wait time longer than David. Do you see what the answer is now? But pretend my answer doesn't exist. Does it make sense, Clay, what the answer is right now? Like, could you pick from here the answer for what % of customers? Because the whole curve is 100%. So the whole curve is 100%. And could you pick out what % had a wait time longer than David, knowing that the whole curve is 100%? So the answer, but it might be trickier with the 85 on there, which doesn't exist on the real question. It's cool. We're about to go full circle back. I teach at 12:10. Do teach at 12:10. And so what if there was 85 here, though? So I'm going to ask this, though. If we had drawn the line right here, so let's take our line. Hypothetically, if the line was right here, how much area would that be? So if the line was right there, Clay, how much area would this be? So if we had the line right there, how much area would this be from here over? So if the line was right there, how much area would that be from that over? If the line was there, how much area would it be? It'd be 50%. But it looks like our area is what to that? Our area is going to be what to that? Like the area we have is going to be what to 50%? I'm never going to click that line again now, am I? No. Wait. Our area is going to be more than 50%, right? So our area, here's the line. Our area is more to 50%. But how about if I move the line over here? If I move the line over here, then our area is what? Well, let's figure out what this area is. How much area is from here? And we'll just do like kind of a line going here over. How much area is from there over? Now, this one might be a little bit tougher, but we have to remember 68 is between here. So 68% is between here because empirical rule. And that leaves 16% below here. And on the top side would be 16%. So it'd be 84. If you think about 16% below, it's 84% above. And do you notice what that does to the other answer? This would have to be less than 84. So that would eliminate the 85 right here. And so we do things like that sometimes. So 85 could be eliminated because this has to be less than 84%. So 84 would be eliminated. We could put 84, but I mean, it has to be less than 84. So does that make sense that the answer we would choose right here, if anyone's wondering, is going to be 75%? So the answer has to be between 50 and between, because it has to be more than 50. Oops. The answer has to be more than 50%, and it has to be less than 84%. 84% would be too much, and we wouldn't do multiple. We wouldn't do it if it wasn't multiple choice. Good question right there, Kevin. We wouldn't do it if it was a multiple choice. It would say something like, if it wasn't, it would say like, here's a non-multiple choice version of the question. Here's a non-multiple choice version of the question. Okay, here's the non-multiple choice version of the question. Clarissa. What is the answer now? And the answer is basically on the screen. So now it says David had a z-score of -1. So what is the answer to this one? So this is the non-multiple choice version. So now you do not have the answers down here. This is the non-multiple choice version. How would you solve this? This is the non-multiple choice version. And the answer is on the screen. David has a z-score of -1, so we're pretending this is a non-multiple choice now. Oh, no, no, no. I didn't want to eliminate both those. Why did I do both those? I guess we kind of need that 68. I'll draw the 68 again, because it's part of the solve. So the answer would be 84%. What about another non-multiple choice version? What about this right here? David has z-score of 2, another non-multiple choice version. What percent of customers wait longer than David? David has a z-score of 2. So now we need to move our line for David all the way over to here. And we have a bunch of things that are not going to help us, so we're going to eliminate those. And we're going to draw some stuff to help us. $83. Double check. I'll show the graphic again here in a moment. We are interested in this area right now. So be solving this. 2.5. Nice job right there, Kevin. Yep, 2.5. Because you just subtract from 100 and then divide by 2 to get the remaining. And anytime you travel across your arrows, you want to make sure you have 100% of the curve. So if you travel all the way across arrows like this, yeah, that's the biggest thing, Clay. It's just practicing with this graphic. And we did this earlier. So if you weren't here at the start, we drew out all the numbers. And so we have the percentiles in green at the bottom. These are the percentiles. And then these are the areas between. So if you didn't see this at the start, we practiced by drawing this, which makes the question a lot easier. Then it'd be 2.5%. So this graphic right here can really help. And we did this at the very start. We talked about the percentiles at the start. So great job, everybody. Let's throw some more 20 points to everybody. Mubot, how you doing?
I am Mubot.
Oh, man, you're so good, Mubot. You're awesome. Let's go say hey to Mubot. Any last kind of quick questions about the test? We are going to, I'll send out like the review stuff. Let me make myself reappear. Go say hey to Mubot. Mubot, you doing all right?
I am Mubot.
You need to calm down, Mubot. Lost my favorite song. Can you go over number 5, part 2? Which one is that? I might, let me see how much time I got. Thank you, Marley, for being here. Let me see. I'm just playing some music. Number 5, part 2. I think we might have done this one yesterday. Did we? I'm going to do a brief solve on it really quick. I'm going to use the graphic. I'm going to use the graphic. So let's see if we can deduce it with the graphic, because I teach in 40 minutes, and I'm going to answer some emails before I teach. So let's go. Let's head back. Mubot, we got to say bye to you.
I am Mubot.
Mubot, calm down. Calm down, Mubot. Don't be mad at us. We have work to do. There is work to do, Mubot. We can't hang out with you all day.
I am Mubot.
Thank you, Mubot, for understanding. This is just random class. I talk to Mubot. He talks to me back. He gives me help. Okay, let's take a look right here. I'm supposed to take the exam during the 12 to 4 time, and Canvas hasn't made it open yet. It should be, hopefully, Clay, let me go look at that immediately after this, okay? I'll make sure it's open for you, Clay. I hopefully haven't gotten emails from other people, so I need to head off right after this, Clay. I'll make sure it's open. So, yeah, Clay was saying that. Clay, yep, let me take a look at that right after this, Clay. What percent of batteries expected to last more than 2 years? So let's Z-score more than 2 years. Who knows what the Z-score is for more than 2 years? You're welcome, Clay. That is #1 task right after this. And hopefully I don't have emails from other people from last night saying the exam didn't load because busy morning. So what is the Z-score for this right here? We need to take observation minus mean over standard deviation. This is going to give us the Z-score. So the Z-score for this right here is going to be 2 minus 2.5 divided by 0.32. And that's the Z-score, -1.56. So let's go down to our graphic. Let's put the Z-score. Oh, yeah, I had to sneeze. So we're going to put the Z-score on here. The Z-score was -1.56. And let's see. We want to know percent of time, I think, longer than this. So we want to know this area right here. Okay, let's do the same thing we did with the previous problem. You ready? So great job right there, Elizabeth. So with this, we want to know that shaded area, but this would be too little area. Does that make sense? Like this would be too little. Like this is not enough. But what percent of area is above right here? So above the line right here is what? Like if you look at this line and then you go above it, and we've got our cheat sheet right here to help out, what percent of area would be above this line now? Because we can see below it, what percent of area is below this line, but this is too little. This is too little right here. This would be too, if like we shade above here, that's too little. But from here over is how much? From here, right here over is how much? Because we can see what's below it. So what would be above it? So if 16% is below, Kevin, great job, Kevin. So then we're going to bring this back over here. And then we're going to go right here. So it has to be more than 84. But then it has to be less than what? It has to be less than what? Because now we put the line right here, as close as we can. So we put the line right here, and it has to be less than what? So now from here over, this line now over, this is too much. Like if I were to shade this in, this would be too much area. Like if we were to shade from there over, that'd be too much. So it has to be less than this. So total I have shaded now what from here over? Well, this is 2.5 below here. So what's above here? So there's 2.5 below here. So what is above this current spot? Like above here is 97.5. So if you were to travel across these areas, you'd get 97.5. And that would be too much. So the answer has to be between 97.5 and 84. So does that make sense here that the answer is going to be more than 84 and less than 97.5? So that's what we see right here. It has to be more or less than 97.5, but more than 84. So, yep. Does that make sense right there? I know that was kind of a quick solve. We did a lot today. You're welcome, Marley. So glad that it helps out to kind of see it. Just make sure to Z-score it, and then you can use your curve that you have drawn here. That's got it, everybody. Let's play some quick music because love some music. We're going to go take a look, Clay, get it all figured out. Hop back here to space. I will see everyone later. Class time. Say hey. Mubot, say hey to everybody.
I am Mubot.
Mubot, you're awesome. With that, we will be back later for more office hours. Swing back by, I think, like 3:30 your time or so. Check it out. Office hours posted online. I will see you later. Bye for now, everyone. Bye.